we're going to do, this is the last topic we're doing on our unending review session, it seems like. And then we'll move on to some new stuff. I'm really kind of excited to do that. So, Jalen, Marissa. Okay, so real quick, so properties of exponents. Properties of exponents. Before we dive into this, just remind me, if I talk about a power, so a power would be something like, x cubed, for example. We could even do something like 2x cubed. Okay, what do I call a number that's being multiplied by variables or functions? You know what I call that? Starts with a C. Coefficient. Yeah. Very impressive. Okay, what do we call the thing that is being taken? Variable. No, it is a variable, but just in general, it could be a number too. The thing that's being taken to a power, what do we call that? Starts with a B. No. Lots of wrong B's there. Base. That's it. It's the base. And what do we call the number that's raised up? Exponent. There we go. So all that stuff together we could call a power, right? Okay, so what do we do with these powers? We need to be able to work with powers, and the algebra that goes with powers is just a little different than the regular algebra that goes with just plain old numbers and variables, right? So we got to be able to do some stuff here. What happens if I want to be able to, let's say I want to be able to multiply something like x squared times x cubed. How do I deal with that? Okay,
You multiply the exponents, right?
you don't multiply the exponents. You add them. Okay, here's how we can remember that. This is the same. This is called like a product of powers. I don't care if you remember what that's called. But here's what I do want you to remember. You fill in the blank. When you multiply like bases, you add the exponents, right? So that's what we want to remember. Right? So what do we mean by like bases? They're, like in this case, I've got x squared times x cubed. Why are those like bases? They're both x's, right? If the bases are the same thing. If the bases aren't the same thing, we can't do this. Like if I had x squared times y cubed, what's my simplest answer? X squared y cubed. That's it. There's nothing I can do with that because they're not like bases. Okay? Question?
So if they have coefficient boundary, then they
Okay, so yeah, so what about that? Let's make it a little tougher. So what if we had something like, let's say instead, say we had 2x to the 5th times 3x to the 4th. Good question. What do we do? I mean, okay, I know what you're getting at, but like terms, remember what terms are in that. Terms are things that are being added or subtracted, right? So like if we had 3x plus 4x, we'd say that's 7x, have like terms there, right? In this case, nothing's being added, so we don't have any terms. We just have factors. Factors are things that are being multiplied. But I will give you a hint. How many things are actually being multiplied up here? Well, okay, the way I've got it written, there are 2. But I don't really need these parentheses, right? I could just say instead, I could just say 2x to the 5th times 3x squared. Now, how many things are being multiplied now? How many factors are there? 4. Seeing 4. What are they? 2 times x to the 5th times 3 times x squared. So that might give you a hint how we're going to deal with this thing. Remember, when I'm multiplying factors out, I can commute them, I can move them around in a convenient pattern, right? What might I do? What do you think, Emma?
Well, no, I'm saying, wouldn't that be like 9 because it'd be 2 times x.
Well, okay.
Times x times x.
So you could argue that, but usually what we would say is x to the fifth just counts as a factor. Because a lot of times, it's a good question, but like what if we were doing something like this? X cubed distributed over 2x plus 3 or something, right? We would just say, okay, we're going to take this factor and distribute it over that one, right? Okay. So what do you think I do then with this? Too far. What do you think I'm going to do? I can multiply those 4 factors in any order. How would I want to maybe group them? What do you think? Just throw, it can be wrong, just throw something out. Somebody. What do you think? Okay, how about if we do the 2 times 3 first, times, that leaves me with x to the fifth times x squared. I like that. Right, we're going to do the number, we'll do the constants first, or the numbers. What's 2 times 3? X to the fifth times x squared. How do I get x squared? It should have been x to the fourth. That was supposed to be a fourth. So what do I get? That's it. Okay. All right, next one. So we multiply like bases, we what? Add the exponents. Good. Okay, so now it's something different. What if I do this? What if I do something like x squared cubed? Okay, now I multiply it. If I'm taking a power to a power, then I multiply the exponents, right? So this would equal x to the 2 times 3, which is x to the 6th, right? Does that make sense?
Yeah.
Think what this really means. If I do x squared cubed, doesn't that mean if I cube something, I'm multiplying it by itself 3 times, right? So isn't this the same thing as x squared times x squared times x squared? Okay, well, we know that's x to the 2 plus 2 plus 2 is 6, right? Okay. All right, how about this? What if I've got something like, let's say, x times y squared cubed? Ah, okay, good. So what we know here is that if I'm taking a product all to a power, so I've got a bunch of stuff in parentheses that's being multiplied, so we call that a product, right? That times that. I take a product to a power, I can distribute the power to each of the factors inside, right? So this would end up being x cubed times x squared cubed, and we know x squared cubed is just x to the 6th. So I'd get, oh, sorry, that's supposed to be a y. X cubed times y to the 6th. Okay, what if I did this? Make it a little tougher. What if we did 3 x to the 5th y z squared squared? Everybody get out your notebooks. You don't have math, you should have to do that. You got your notebooks. You just try this one on your own. Okay, so what do we think here? How many things are being multiplied together inside the parentheses? So how many though? 4. Yeah, I've got 3 is 1 times x to the 5th times y times z squared. So I've got a product of all 4 of those things taken to the second power. Jaylyn, what am I going to do with that 2? You're on the right track. Okay, good. I'm going to multiply it to the 3. Well, I'm going to distribute it, right? So I'm going to distribute the exponent to each of those places. Now, when a y is by itself, we don't write it, but what's the exponent? So 1, okay. So then I'm going to get 3 squared times x to the 5th squared. What's that going to be? 10th, right? Because if I take a power to a power, I multiply the exponents, right? So that's the same thing as x to the 5th squared times y to the 1 squared times z squared squared. Well, what's 3 squared? 9. X to the 5th squared would be x to the 10th. Y to the 1st squared would be y squared. Z squared squared would be z to the 4th. Okay? Good? Okay? Next. Okay, what if we divide like basis? So what if I do x to the 7th divided by x cubed? What's the rule there? You subtract. Good. Okay, now there's an extra rule I want to give you here, though. This is on the assignments. I'm going to always ask you to write your answer in terms of positive exponents, which is fine here. I end up with x to the 7 minus 3, which is x to the 4th. No big deal. Okay, but what about this case? What if we've got something like x to the 4th divided by x to the 9th? What do we do? What do you think?
Would be negative x to the 5th power, so the exponents are positive?
No. We could follow our original rule, and that's fine. So you told me I subtract, and that's okay. I'd get x to the 4 minus 9, which is x to what power? The negative 5. Okay, but there's another rule that comes into play here then. It is. Okay, so if I have a negative exponent, fractions are always broken into 2 parts, right? There's only 2 places you can go in a fraction. The numerator on the top or the denominator on the bottom. So here's the rule. Whenever you have a negative exponent in one part of a fraction, you move it to the other part of the fraction and it becomes positive, right? So this would then becomes 1 over x to the positive 5. If the exponent's negative on top, it's positive on the bottom. Right? Okay, while we're on that subject, what would I get if I had 1 over x to the negative 3? What would that equal? X to the 3 on the top. Because if the exponent is negative in the bottom, it's positive in the top, right? Okay, everybody with me? Okay. So that's that's the negative exponent property. Easy one. But could we have taken a shortcut with this guy to get from there over to there? It's fine to do it this way, but there's another way to think about this. Instead of subtracting 4 from 9 on the top, there's another way you can think about these quotients like this. If I'm dividing like bases, what I would tell you to do, it's a little bit of a shortcut, is instead keep the base where it's the most powerful. 9 is greater than 4, right? So we'll leave the base on the bottom and subtract the top exponent from the bottom. We get it in one step. Okay, make sense? Okay. And what else we got? Okay, I think 2 more. So what do you think we do in this case? What if I've got, let's say I've got 2x squared divided by 3y cubed to the cubed. What do you think I'm going to do there if I'm, not only am I multiplying stuff, I'm also dividing. And I'm taking all of that to a power. What do you think I can do with the exponent? What can I do? Suggestions? Say it again. 2, okay, good. So we already know that we can distribute the 2 and the x squared are being multiplied, so I ought to be able to distribute the exponents of both of those. But it turns out I can also distribute to the bottom, right? So the 3 also gets distributed there and there. So we end up with 2 cubed times, what's x squared cubed? X to the 6th. If I take a power to a power, I multiply. Divided by 3 cubed, and y cubed cubed would be y to the 9th. What's 2 cubed? What's 3 cubed?
27.
There you go, 27. So that's my answer. Okay, I got a real tricky one for you. What about this? What if we do?
Do we ever deal with the 65?
No, that's as much as we can do, because 8 over 27 doesn't reduce, and I don't have like bases there, so I can't do anything with it. Okay. Now, here's one thing you do know too, that's just kind of a good thing to keep in mind. If I can't reduce 2/3, then would you agree there's no way I'm going to be able to reduce 2 cubed over 3 cubed? Does that make sense? Because think what that means. 2 cubed over 3 cubed just means 2 times 2 times 2 over 3 times 3 times 3. The only factors in the top and the bottom are just 2's and 3's, and 2's and 3's don't reduce. Make sense? Okay. So you know that if that original fraction doesn't reduce, then after I expand it out, it's not going to reduce either. Okay. How about this one? What if we've got 4x squared over 5yz cubed to the -2? Think about that one a little bit. What are you going to do? What about that negative exponent? What did we say about negative exponents? Okay, so yeah, when we have a negative exponent, it becomes positive when you send it to the other part of the fraction, whatever you're applying the exponent to, right? Well, in this case, I'm going to end up distributing this -2 all over this thing. Everybody agree? So we can do this. There's a great trick here. It doesn't really show up in the book, but there's a great trick. Whenever you have a fraction to a negative exponent, I could immediately do what to the fraction and make it a positive exponent? Flip it. Yeah. So I could write this as 5yz cubed divided by 4x squared to the +2, and now it's a lot easier. Right now, all I've got to do is just distribute the 2 to each part. Okay. So what's 5 squared? I get y squared. Z to what power? No? 6. Taking a power to a power, so I multiply the exponents. On the bottom, 4 squared. And x squared squared. What's that?
4.
Good. X to the 4. Okay? All right, last property. Very simple one. Okay, what's the answer?
0.
No. Yeah. Anything taken to the 0 power is always equal to 1. It doesn't matter how complicated this thing is that you're taking to the 0 power. It could be really hard, like this. But if I take it to the 0 power, it's equal to 1. Anything to the 0 always equals 1. Okay? So that made that a lot easier, right? Okay, so just let's put a couple of these together once, and then I'll let you work on the assignment. So try, what about something like this? What if I do seems like a lot of stuff going on. We just got to follow order of operations, right? So what are we going to do first year project? Where are we going to work? Okay, so let's flip it over. Good idea. Let's flip this whole thing over. Okay. You know what? Before we even flip it over, though, let's do one thing. We're not going to distribute the -2, but before we have to flip it over and write all that stuff out, let's actually follow order of operations, and we're going to work inside the parentheses first, right? So inside the parentheses, we could probably make that look a lot easier. Like the top, for example. We've only got, let's look at all the x terms, or x factors. So there they are, right? What's going to be the result of multiplying x to the 4th times x cubed times x to the 0? X to the 7th, right? X to the 4 plus 3 plus 0. So I'm going to get an x to the 7th, and I've got a 2 on top. What about the 3's on the bottom? What about the y's? I have y cubed on top and y to the 7th on the bottom. What's going to happen? Subtracting. Where am I going to leave the base this time? On the bottom. 7 is bigger than 3. And so I end up with y to what power on the bottom? 4. 7 minus 3. And then I've got a z squared that just got stuck there. Okay, so now we simplified everything inside. That's good. Now we can go ahead and do our trick where we've got this negative exponent. So we'll just flip the whole thing, right? So we end up with 3y to the 4th z squared over 2x to the 7th to the positive 2. Now what do I do with the 2? Distribute it. Distribute it to each of the powers, right? So if we do that, if the 2 gets distributed there, 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 and there. What do I get on top? What's 3 squared? 9. Y to the 4th squared. Good. Y to the 8th. Z squared squared. 2 squared. X to the 7th squared. That's it. Okay, make sense? All right, let's go.